Alright guys, yesterday we did long division. Today we're doing something much, much better called synthetic division. It's a quick way to do long division, but you can't do it all the time. So that's why we had to do long division yesterday, because it is necessary sometimes. So let me show you quickly how to do this great way of dividing. Okay, everybody knows fraction bar means divide. So really this problem says that numerator right there divided by the denominator. Now, here's the deal with synthetic. You can only do synthetic division when your divisor down there is a first degree binomial, meaning the biggest exponent is 1, and there are two terms like x plus 1, x minus 5, x plus 4, stuff like that. So what we do is put a little backwards L. I'm going to call it a box. Then I'm going to put the coefficients, the 3, the negative 2, the 2, the negative 5. All those numbers came from my numerator. And here's the deal. In my box, or my backwards L, I'm going to put the number that would make the denominator be 0, or the opposite number that's on the bottom. I'm going to put a negative 1. Here's how the process works, okay? You start out by bringing the first number down below this line. Every time you bring a number below the line, you multiply by what's in the box. So I'm going to do 3 times negative 1, which is negative 3. You place it underneath the next number. You take the numbers in that column and you add them up. Again, every time you get a number on the bottom, you multiply by what's in the box. Negative 5 times negative 1 is positive 5. Add them up. Number on the bottom, multiply by what's in the box. That's negative 7. Add them up. Now, I'm always circle my last number because that's going to be my remainder. Okay, now, don't forget, well, you don't forget, you don't even know this yet. But your answer, your quotient, those numbers on the bottom row right there, those are the coefficients of your quotient or of your answer. So I'm going to start my answer with 3. And here's the deal also. Because the problem started with x cubed and you're dividing by x1, that means your exponent is going to be x squared. The exponent in your answer is always going to be 1 less than the exponent that you started with. Okay, the minus 5 is going to be the coefficient on your x. The x's are going to decrease. The 7 will have no x because the x's are done. And then I'm going to take that minus 12 and put it over our divisor like we did yesterday. And there it is. All right, piece of cake. That's so much better than long division. I'm going to show you one a little quicker. Okay, here we go. I'm going to talk like you've seen one, because you have seen one. Okay, first of all, I'm going to do my box, or backwards L. What makes the bottom 0? 3 does. And now I'm going to list all the coefficients. Got negative 1, 4. Now, one thing you do have to be careful about is this. There is no x to the first term, so you have to put a 0 on its spot. That's a must. If you're missing an exponent, you must put a 0 on its spot. Okay, here it goes. Bring the negative 1 down. Multiply. Add. Multiply by what's in the box. Add. Multiply by what's in the box. And that's my remainder at the end. And remember what these numbers are on the bottom. They're the coefficients of your answer, or your quotient. So I'm going to get negative 1 x squared. Also remember we start at 1 degree less, or 1 exponent less than we started. 1x, that 3 will have no exponents. The 18 is going to have x minus 3. And there you have it. That's all it is, synthetic division. Okay, one last skill today is called the remainder theorem. And basically, I know if you read this, it says if a polynomial f of x is divided by x minus k, then the remainder is r equals f of k. Here's what it's trying to say. If they give you a polynomial function and ask you to plug something in like k, if you will just do synthetic division using x minus k, it's going to be exactly what you get if you plug it in. That probably didn't make sense either. Let me show you what I'm talking about. One more slide. All right, here we go. F of x is this great big polynomial. They want you to plug in 2. Instead of taking the time to plug in 2 for x4, 2 x cubed, and 2 for x, and working that all out, I'm going to do synthetic right here. So it's going to look like this. I'm going to do my backwards L, or box. I'm going to put a 2 in the box. You actually put exactly what's there. That's one difference. If they tell you to plug in 2, you put 2 in instead of doing negative 2. All right, put your coefficients, 5, 2, 0, because I'm missing an x squared, negative 20, negative 6. Now watch what happens. So I'm going to go pretty quick. Bring the 5 down. Multiply, that's 10, add, multiply, 12 times 2, that's 24, add, 2 times 24, 48, add, 2 times 28 is 56, I get 50, remember I always circle the remainder. Now here's the deal, here's the difference. What that 50 represents is, if I would have plugged in 2, like f of 2, if I would have plugged in 2 and for all the x's, I would have gotten 50. Okay, just a short way to plug something in instead of having to plug it in for all the x's and work it all out. Pretty cool. All right, that's really it. Not a bad day. I'll see you when you come in tomorrow.